When most people think of lightning, they imagine towering thunderclouds, heavy rain, and loud thunder. But lightning does not always need a storm cloud to form. In rare cases, electrical discharges can occur in clear or nearly clear skies, driven by forces most people never notice. One way this happens is through something called dry lightning. In these situations, storm clouds form high in the atmosphere, but rain evaporates before reaching the ground. From below, the sky may look calm or only lightly clouded, yet powerful electrical charges are still building overhead. Another form is volcanic lightning. During explosive eruptions, ash particles collide violently inside the eruption plume. These collisions strip electrons from atoms, creating massive electrical imbalances. The result is lightning flashing through clouds of ash instead of water droplets, sometimes with no traditional storm clouds nearby. Lightning can also form during intense dust storms. As dust particles collide and rub against each other, they exchange electrical charge. In large desert storms, this buildup becomes strong enough to trigger lightning bolts. Even in completely dry air, there is also a phenomenon known as heat lightning, often misunderstood. Heat lightning is not a separate type of lightning, but rather distant lightning from storms over the horizon. The clouds and thunder are too far away to see or hear, leaving only brief flashes illuminating the sky. In rare cases, powerful electrical fields near the ground can trigger upward lightning. Tall structures like mountains, towers, or wind turbines can launch electrical discharges upward into the atmosphere without a storm directly overhead. These bolts move from the ground toward the sky, reversing what most people expect. All of these events share the same fundamental requirement: a strong separation of electrical charge. Whether caused by ash, dust, ice, or rising heat, lightning forms when the atmosphere becomes electrically unstable enough to release energy in a sudden discharge. Storm clouds are the most common way this happens, but they are not the only path. Nature can generate lightning wherever particles collide, charges separate, and the air can no longer hold the imbalance. Lightning without storms reminds us that electricity is constantly moving through the atmosphere, usually invisible, occasionally spectacular, and sometimes appearing where we least expect it. Like and subscribe for more curious science videos every day.